Hey everybody, this is Mr. Beckstrom. Today we're going to take a look at section 3.8. This is on implicit differentiation. It's actually a pretty short section here, so there's really only one concept that we're going to be looking at, and that's how do we solve these equations where we aren't explicitly solving for y. So we know that for something to be a function, we could put it into like a y-intercept form, or y is equal to. But what happens when we have an equation that's like a y squared in it, right? That doesn't have a single solution for y. We can use what's called implicit differentiation. And that's where we're going to go ahead and we're going to take the derivative of each term, and we're going to do something a little bit special when we get to the terms that aren't x or aren't our independent variable for that equation. So let's go ahead and just look at a few examples and see if we can kind of figure this out together. Alright, the first one I want to take a look at is this function here. The sine of y is equal to 5x to the fourth minus 5. Now with this one, we could go ahead and take the inverse sine of both sides and actually solve for y, and then take the derivative that way. But then we're finding the derivative of the inverse sine function, which we actually haven't taken a look at yet. We haven't looked at the inverse trig functions yet. So let's use implicit differentiation to solve this one. So basically there's three terms here. There's sine to the y, there's 5x to the fourth, and then there's 5 over here. And I'm just going to do each one of them separately. Now if the variable in there is my independent variable x, I'm just going to take the derivative as normal of that term. And I'll show you what we're going to do. But if I take the derivative of another variable other than x, like y in this case, then I also have to multiply that term by dy over dx. But I just write y prime, which is the same thing, just a shorter hand notation. So let's take a look at what I mean here. So the derivative of sine to the y, well, this is not x, so we're going to have to also multiply it by y prime. But the derivative of sine of something is cosine of something, so this is going to be cosine of y times, I'll put it over here, times the derivative or times y prime, because we took the derivative of something other than x, so it's going to be y prime times the cosine of y, and that's going to be equal to, now we're taking something with x in it, so it's just going to be like normal using the power rule, so that's going to be 20x cubed, and then we know that the derivative of a constant is just 0, so that goes out. So here is what we're left with. Y prime times cosine of y is equal to 20x cubed, and we want to solve for y prime. So y prime, that's our derivative of y, is equal to, in this case, 20x cubed all over the cosine of y. Alright, let's take a look at another example here. Alright, so here we're actually having two terms that have y in it. So we have this term and this term. So go ahead, see what you can do. Try it out. And remember, we're solving for y prime, or you can write it as dy over dx. That's how the book writes it out, but it's the same thing. And see how you do, and then unpause the video, and we'll go through the solution. Alright, so we have three terms here, the x, the y, and the cosine y. So we're going to take the derivative of each of them independently. So the derivative of x is just 1 plus the derivative of y. Remember, this is not x, so we actually have to multiply by y prime as well. So this would be, derivative of y is 1, but we're going to have to multiply that by y prime, and this is equal to the cosine of y. Once again, it's something other than x, so we're going to have to multiply by y prime. If this was the cosine of z, we'd be multiplying by z prime. If it was the cosine of, oh my gosh, what is another letter? T, it would be the t prime. So whatever other letter it is, we just don't have to do that when it's the x, because x is our variable of change here. Alright, so the cosine is negative sine. So this is negative sine of y, because that's the derivative of cosine of y. And then this is going to be times y prime. So it's going to look something like this. So now the next thing I want to do is I want to get all of my terms with y prime on one side. So I'm going to keep this over on the left, so that's y prime. I'm going to take this and bring it over here, so that's going to be a plus. I'll put the y prime in front, y prime times the sine of y, and this is equal to, and I'll bring that 1 and bring it over there, negative 1. So I want all of my terms with y prime on one side and everything else on the other. And the reason I do that is because now I can factor out a y prime, and I'm going to get 1 plus the sine of y, and that's equal to negative 1. And then finally I can just divide both sides by this to solve for y prime. So y prime is equal to negative 1 over 1 plus the sine of y. That's it. All right, let's take a look at another example here. All right, we are constantly getting harder here. So this is cosine of y squared plus x is equal to e to the y. So go ahead, see how far you can get. Pause the video. When you're ready, we'll go through the solution. All right, so we have three terms here. Cosine of y squared. Well, the cosine of y squared, we can use the chain rule for that, where y squared is the inner function and the cosine of u is our outer function. So this is going to be the inner function, which is 2y. Oops. So remember, when we're taking the derivative, we can just kind of write it like this if we're not implicitly solving for y here. So this is the derivative with respect to x of this function here. So the reason that we have to do that extra y prime or z prime or whatever it is when we're not doing x is because we're differentiating with respect to x, so we don't have to do it with the x's. All right, so here the cosine of this is the cosine of the inner function. So the cosine of y squared is just going to be using the power rule as 2y, and I just took the derivative of something, of a variable other than x. So I also have to multiply that by y prime. Every time I do that, every time I take the derivative of something other than x, I've got to add whatever that letter is, prime. All right, times the derivative of the outside function. So the derivative of cosine is negative sine. I'll bring the negative out front and write the sine of y squared. All right, plus the derivative of x is just 1. I don't have to put an x prime because we're taking the derivative with respect to x. And this is equal to e to the y. I can use the chain rule again. So this is the outside function, which the derivative of the outside function is just e to the y, times the derivative of the inside function. The derivative of the y is just 1 times y prime, because I just took the derivative of something other than x. So we put the y prime here. So this is what it gets set up at. So remember our strategy. Our strategy is get all the terms with y prime on one side and all the other terms on the other side. So we have a y prime here. So I'm going to write this as negative y prime times 2y times the sine of y squared. And then we're going to bring this over here. So it's going to be a minus y prime e to the y. And then take the 1, bring it over there. So that's equal to negative 1. Now I can pull the y prime out. Oops. Let's pull the y prime out, not negative y prime. So y prime comes out, and I'm going to have negative 2y sine of y squared minus e to the y is equal to negative 1. And then the last step here, the last step here is just to divide by this big thing here. So y prime is going to equal to, let's go ahead and divide the negatives out of everything. So we'll have 1 over 2y sine of y squared plus e to the y. This should be a y there. I know it kind of looks like an x. Let me just make sure I fix that. All right. And that's it. That's it. All right, so let's take a look at one more super hard one, and then we'll be done with these. All right, here is a good one. So this is x times y plus 1, all quantity cubed, is equal to x minus y squared plus 8. So give this puppy a try, and when you're ready, we will go through the answer. All right, so really I've got 4 terms here. I've got this 1, 2, 3, and 4. So we're going to do each one separately. So this one right here is something in the inside raised to the 3rd power. So that is chain rule right there. It's kind of like u to the 3rd power, where u is equal to xy plus 1. So we're going to take the derivative of the inside for this one. So it's going to be, oh my gosh. So we have to also take the derivative of this when we do the inside. So let's do that off to the side here. But before we do that, remember we can leave it as putting the d over dx in it in order to kind of know where we are. So here I'm going to do the derivative of the inside. So the derivative of this is, instead of doing the derivative of xy, I'm just going to leave it as, I still need to take the derivative of xy, like that. That means I haven't actually taken the derivative of it. And this is going to be plus, derivative of xy. Remember, the 1 is going to fall off, right? So that's just 0. So derivative of xy, and this could be times the derivative of the outside. And the derivative of the outside is basically u cubed, so that would be 3u squared. Using the power rule, so that would be 3, well, horrible 3. All right, times 3. It's not much better, but, and our u is just the inside function here, so xy plus 1, right? And then raised squared. So this is just that term there on the left, and I still need to do this xy, and I'll go ahead and do that off to the side. And this is equal to the derivative of x is just 1 minus, we're going to do 2y, and then we have to put the y prime there because we just took the derivative of something other than x, plus 8, so that's going to fall off there. So this is what we have. So now off to the side, I want to do the derivative of xy, so I'll use the product rule, and that's the first times the derivative of the second. Remember, the derivative of y is 1, but we have to multiply it by y prime because I just took the derivative of something other than x, or a variable other than x. So x times y prime plus the second term, which is y, times the derivative of the first. Derivative of x is just 1. So this is the derivative of xy. It would be xy prime plus y. Now we put that back in there, and I'm going to get x y prime, right, plus y. And remember, this is all, I'm just substituting in here, it's all going to be multiplied by this. I'll bring the 3 out front, and then I've got x plus 1, xy plus 1, quantity squared, and that's going to be equal to 1 minus 2y y prime. Whew, 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 whew. All right, so now what do you think we should do? All right, now all of this mess has to be basically multiplied out, distributed out, because we have a y prime in there, and we're going to need to get that y prime term by itself. So let's go ahead and work on this side. So first I'll get 3xy prime plus 3. If I distribute that 3 in the first binomial there, and that's going to be times xy plus 1 squared is equal to 1 minus 2y y prime. And now I'm going to need to FOIL this part out here. Oh man, this one stinks. I hope you watched through all this. Alright, so let's FOIL this part out first. So I'm going to have 3xy prime plus, oh, I forgot to put the y there, plus 3y. And then this over here is just going to be xy quantity squared. So it's going to be x squared y squared plus 2xy plus 1 squared, which is just 1, is equal to 1 minus 2y prime. And then we're going to have to multiply this big sucker out here. So we're going to get, oh my gosh, so this times this, that's going to be 3x cubed y squared y prime. And now this times this, so plus 6x squared y prime. And then this times that, so that's going to be plus 3xy prime. And then we're going to have that times this. I'm totally going to run out of room here. So plus 3x squared y cubed, and that times that, plus 6 xy squared, and then finally plus 3y is equal to 1 minus 2y y prime. It almost looks like differential equations, doesn't it? Alright, so now that we have everything distributed out, we want everything with y prime on one side. I'll try to compact it up a little bit here. So this one, so 3x cubed, and I'm going to go ahead and save myself a little bit of a step here. I'm going to go ahead and already pull the y prime out. So y prime, and then anything that has a y prime is going to come over on this side. So 3x cubed y squared plus 6x squared y plus 3x. And we also have the negative 2y y prime over there. So I'm going to add it to both sides. So plus 2y. And is equal to, the 1 is already over there, so 1 minus 3, my mouse is messing up here, 3x squared y cubed plus, oops, not plus, it's going to be a minus because we got to bring it over there. Yeah, my mouse is not working. I'm going to get this though. Okay, so minus, we got 6xy squared, and then we got minus 3y. And then the last thing is, and I'm not going to do it because I am tired, but y prime is going to be equal to that side divided by this, because we're going to divide both sides by this. So I will let you do that part because my mouse is messing up. But so somebody check my work there, make sure I didn't mess up anywhere. I'll give you a little bit of extra credit if you can find somewhere where I left a value out or something. But man, that was a crazy hard one. All right, y'all. If you have any questions, please let me know, and I hope you all have a great rest of your week. Thanks.